professor of computer science at Durham University, specializing in human-computer interaction, formerly a full professor in human-computer interaction at the University of Leicester and senior research fellow at ETH of Zurich. In her talk, Effie will present her study on the use of eye tracking methodology for evaluating game experience and the potential of other psychophysiological measures for game research. It's a pleasure and an honor to give the floor to our Keynote professor, Effie Lowe.
Thank you very much for the introduction. So I'm sorry that the talk has to be moved to today because yesterday there had some technical problems. So I explained a little bit already to Francesca because of the license issue. And the laptop I used yesterday was brand new. So today I use my old laptop to make sure that it works. So the title of my talk is Evaluating Gameplay Experience Beyond Questionnaire. So thank you for introducing the background. So I hope everything's worked now. Is it okay? Yeah. So I hope everything's worked fine. Manu, is this okay? Yeah, please signal me if something wrong. So as mentioned, that I now working in Durham University. It's in the northeast of England. So you can see on the map, it's very close to the coastline. So we receive quite a lot of storm these days. So Durham is a top 100 worldwide university. So and also top 10 in the UK. And this is some number, facts and figures about the student number and staff number, and it is expanding. So in 5 years' time, you will see more of the departments and colleges will be in Durham. So you can see the beautiful side of Durham, the two landmark buildings here, Durham Cathedral and the Durham University College. So, and the cathedral, so if you're a Harry Potter fan, you may recognize it. So the University College is quite old buildings, more than 900 years old. So one of our 17 college, the students really live there. So it's their privilege. So, but our computer science building is pretty new. It's only 2 years old. So yesterday I tried to do a presentation in that building, but today I do it from home for safety's sake. So as Manuel already explained, so I'm a full professor in HCI, so I have been in usability and user experience for a long time. So long time, I mean, or more than 2 decades now. So, and I work on some basic theoretical issue, also methodological issues, and apply them to technology enhanced learning, affective computing, and human AI interactions. So you can see many different areas. So, but today I focus on gamification and game-based learning. So technology enhanced learning, I've worked on many different projects on that. So game is one of them. So this is the outline of my talks. First, I will talk about some basic idea of questionnaire, but I assume that many of you already know the basic stuff. I just want to refresh your memory and put my presentation in context. So maybe you find that part a little bit boring. So I hope I try to make it more engaging. So then I give 2 examples of game experience questionnaire. So one not so good, so you will see why it's so, and the good practice, and then go beyond questionnaire about some kind of different measurement, and also now today we talk a lot about AI, machine learning. This is also play a role in the future evaluation of game experience. So research method in HCI 101, don't worry, I'm not talking about questionnaire design. I'm not going to give a lecture on that. So, but just highlight some of the fact that we usually mention to the students and also early researcher. So questionnaires are really good at getting a large number of response in a short period of time from geographically dispersed population. I think many of you know about that. And we can capture a big picture relatively quickly. So, and questionnaire can measure a lot of different dimensions, attributes, and so you can see the list here. You can add more onto it. So this is really the power of questionnaire. So, and people say that, oh, easy peasy lemon squeeze is the English idiom. So it's to say that some tasks are so easy that you can done in a short period of time with little effort. But actually, if you really do a good questionnaire, so with the valid results, you really plan a lot and also need a lot of effort to build a solid, robust questionnaire. So because the questionnaire first, if you have a good questionnaire, you have to reach the actual population of interest, and also the sampling method is very decisive, and also the question itself must be very well worded and test thoroughly. You can see why it is so later on. So it's not easy peasy. Actually, can be quite difficult. It's a kind of joke. So, and many of you maybe know about the questionnaire design requirements. So the reliability, validity, sensitivity, and usability. So reliability is the result are stable across different administration of the instrument, so you can get a similar result as the diagram here show. And the validity, so you really measures what you want to measure with your tool. So sensitive is how the questionnaires is respond to the independent variable you're using, your testing. And usability, so your questionnaire should be so well designed that your respondent find it easy to answer your questions. So this is the basic criteria when you design your questionnaire. So not that easy to reach. You can see later why it is so. So this is the basic requirement, develop a questionnaire. So then SUS system usability scale. So it's a standardized HCI questionnaire. So it was developed, or it was published actually in 1996. It was developed already in 1980s. So 25 years on. So then it has been used in many different contexts and devices, interactive technology. So, and James Lewis, so he reviewed the SUS in many different occasions or contexts. So you can see in 2017, so he and Jeff Sorrow, so they collect 9,000 so a response to the SUS to test the reliability. But at that time, they didn't test the concurrent validity. So, but still you can see it's quite a strong reliability, 0.91. But then Lewis moved on, so he wants to also test the concurrent validity of the SUS with the other new tool. So you can see he demonstrated this tool is really robust and stable. So yeah, more detail you can see reading this paper. So, and the questionnaire, so for measuring game, you may use SUS to measure game experience, but actually I would say it's not the right tool. So because we talk about game experience, about the emotional dimensions, also other construct I will touch upon later on. So, but if you design a questionnaire, first of all, you have to understand the construct. So you're going to measure. So you find the definitions. So the game experience, what is game experience? So you took from the Army and Maria 2005 paper. So it's an ensemble makeup of players, sensation, thought, feeling, action, and meaning making. You can see it's a really multidimensional and very quite broad. So, and not all game experience questionnaire address all these dimensions, maybe a subset of them. And also another game research groups, Hotari and Hamari, so they emphasize that game experience is co-created, co-construct in interaction between the game and the gamer. So I think all of you maybe agree on that. So, and actually game experience is part of so-called the drive to the movement of the user experience. You heard a lot about usability. We moved to user experience partly because the current, at that time, the usability, so dimension somehow cannot address the emotional perspective or emotional dimension of interaction with technology. So then you can see that the user experience and game experience share some common characteristic. So let's say talk about the temporal dimensions. So we talk about the before playing game, during playing game, and after playing game. So we can also measure the game experience all along this timeline. So I cite the UX white paper we developed more than 10 years ago. So about this temporal dimension research experience can be applied to the game experience as well. So you can see this diagram here. So yeah, I mentioned that multi-dimensional game experience. So this is the attributes, the playfulness, enjoyment, emotion, flow, you can name it. So, and then you can map it into the four major dimensions: cognitive, affective, sensorial, and behavioral. So it all together contribute to the game experiences, also coincide or also consistent, consistent with the definitions I mentioned in the previous slide. So, and there are many different actually game experience questionnaire out there. So Hochberg and his colleague, so they attempt to develop a new one called Gameful Quest. So, and when they develop Gameful Quest, they also review the existing game experience questionnaires. This is the table. So they created, so, and they evaluate in their paper. So, and they include two a questionnaire that I'm going to demonstrate as a not so good practice and good practice. So you'll see why later on. The one is the GEQ, the Game Experience Questionnaire. The other one is User Engagement Scale, UES. So yeah, can see. But then I'll update the publication. So the Game Engagement Scale actually is in 2018. They have a more update on their scale. So I'm going to present a case to reflect about the game so-called research practice. So to see what we can or what we should do to really develop a questionnaire for evaluating the experience and how we should use them. So in a more systematic way. So in 2018, so we published a paper, Kai Play. So you can see the co-authors is from University of Basel in Switzerland. So, but since 2018, I'm now already changed my affiliations. So Eliza also changed now in Aalto in Finland. So, and this is the title of the paper. So it's got honorable mention in the Kai Play. It's a systematic review and validation of the game experience questionnaire. So the subtitle is more important. It's the implication for citation and reporting practice. You can see some interesting observations. So we identify in our review and validation. So, but what is the GEQ? So actually, this is first published in 2007. It's quite a while ago. So as a deliverable from EU project. So the fun of gaming. So actually, I should really give a credit to the research group. They really a significant pioneer initiative to develop such a questionnaire and stimulate the related work. So, and the questionnaires intend to assess 7 different factors, we call it dimensions. So the challenge, competence, flow, immersions, tensions, positive, negative affect. I already presented some of the previous slide about the different attributes in game experience. But unfortunately, so for some reason, I still could not find out. So the formal validation of the questionnaire was never published by the original authors in the peer review venue. So we couldn't find out the reasons, and we are not the only one who identified these issues, because those who use it, some of them try to find out, so have they been fully validated, and what is the peer review so results or in any publications. But this researcher also couldn't find it. So this then actually we also stimulated by their work when they talk about the GEQ validations issue. So we can see some example from the version 2013. This is the last version that group published. So you can see the 7 dimensions here. So challenge, 5 items. I just list one here. I thought it was hard. Is one of challenge, competence, flow, and so and so. So you can altogether there are 33 items in the version 2013. So this altogether. So, and we validate the GEQ, so to see rather the 7 factors is stable or not. So we conduct online surveys, ask people to conduct to answer the question, the GEQs when after they play the game within 24 hours. So, and the original 7-factor structure could not be replicated based on our results. But as I mentioned, that we are not the only group who could not replicate this 7-factor structure. So, and there also some issue about the reliability on the 2 dimensions, 2 factors. So the negative affect and the challenge, and the poor discriminant validity for some of the dimensions. So I want to go into detail the results. You can go to the paper, and some items particularly problematic. So all in all, it seems there's some issue with some of the item and the factors of the GEQ. But anyway, also not only the empirical study, we also do some systematic literature review. So after some process, we identified 73 papers that employ the GEQ. We we only reveal those who use a core GEQ. There's others derived versions, but we didn't look at the post GEQ or kids or other versions. So, and less than half of the paper use GEQ. They provide a reason, a rationale for why GEQ was used. So 31 out of 73. So yeah. And if they provide the reason, so 13 of them say that GEQ was validated. So, but it seems this is not well grounded, because from what I already showed you, this is not the case. And 10 argue that because GEQ was commonly used, so used by the other people, that's why they use it. I think this may be can be a controversial reason you give why you use a certain questionnaire, because other people use it. So then this is also another major insight we get from our review is the citation and reporting practice. It seems some issues, not only on the developer of the questionnaire, also the user of the questionnaire. So, and the few papers report on the GEQ psychometric properties about the reliability, factor loading. So just a handful, they refer to it. So, and interestingly, most of the paper did not report the number of items they use. You can expect that a paper should report how many items they have used, but they actually, quite surprisingly, not all of them report on that. But if they did, so 47 paper, so the number of items they use varies from 33 up to 42, something in between. So why they drop some, why they add some, we just don't know, because the author did not explain how they come up to this number of items they use. So, and then the justification of number of items is really rarely reported. So we find this, the whole thing is quite a bit confusing. So, and basically, so from the two versions officially, so to say, given by the original author, so in 2007 version, there are 42 items, 7 factors, and then down to the 2000 and dropped to 33 items, again, still 7 factors in the version 2013. So, but why 42 become 33 items? So again, we cannot find any publication to explain. So what happened in between? So it's again, is something we can a mystery to be resolved. So about the paper we review, so that 15 way of citing the same resources, so to say, all of them use GEQ, but they have different way to reference the paper. So, and only one of the 73 paper reviews cite the official version in the 2007. So this is this one. And then none of them really give a full list of the GEQ items they use. So it's they may mention the number of items, but they didn't give a full list. I find this really, intriguing. Why so? So, and some citation even refer to a manuscript that it doesn't exist. So you can see that some say that the manuscript in preparation in 2015, but this manuscript actually does not exist. And some say the manuscript, so, but then without the publication year. So it's really, for us, it's really unclear. So how those authors get GEQ items to carry out their work. So because from the citation, so it seems it's something unclear happening in the background. So that the implication for us is there seems maybe unintentionally, so there are some non-transparent and non-replicable and questionable research practice there. And then so it may result in, because we use the GEQ, you claim some results based on the findings. So it may end up the result is not that reliable and not that valid. So, and then it may mislead some of the future, depends on which context. If you're about the educational game, so you may say, oh, this game is enjoyable, and maybe end up it's not the case. So it's been very careful about this, the implications. So how can we deal with these issues? In our paper, we suggest that, so because of these unclear psychometric properties, we have to use the GEQ with cautions. When you use it, maybe in the discussions or limitation, we have to add this remark about the GEQ validation status. And on the user side, so if you use a questionnaire, so we have to be more diligent and transparent. So when you use a questionnaire, so where do you get them, and what are the psychometric properties, and justify why you choose a questionnaire, maybe among the competitive tools. So, and also provide the reason if you really modify the questionnaire, you adopt if the questionnaire is standardized. So, and also about the manuscript in preparation. So it's quite handy to use this term, but you have to find out if a paper already first appeared in 2007, you think one should not expect it's still manuscript in preparation in 2015 or 17. So this is the thing that we make aware that the community should be pay attention to these issues. Okay, so let's look at more so-called good practice. So I demonstrate in contrast is another scale development is the user engagement scale. So again, start with definitions. So what is user engagement? So a quality of user experience characterized by the depth of an actor cognitive, temporal, again, affective, emotional, and behavioral investment when interacting with the digital system. So this is O'Brien. So she worked a lot on the UES. So since 2008, yeah, you can see the next diagrams is in the book. So, and you can see the cycle, so development path, I would say. So I summarize here. So, and in the 2008 and 2010s, O'Brien and colleagues, they first do a systematic literature review and interview study to develop the first version of the UES. So originally the 31 item is 6 factors. And then in 2013 and 16, they go to, they conduct a usage review to see how UES has been used in the community. So they found it used in games, video games is really applicable to our community here, and also in e-commerce, in health, and so and so. And they try to find out, so any strength or weaknesses identified in the usage. And then later on, based on the insight, they develop in other versions and also of the UES reduced to 4 factors and also a short form they provided. So it's a very you can see here. Oh, I should go back to this slide. So, and there are also some interesting phenomena they observe is the tingling. So some author just use some subscale of the UES, not the entire scale. So, and also some of them modify the item. So, and but one important insight they got is the 6 factors not replicable. So then O'Brien and her colleagues again try to do something. So they reanalyze the original data and also got some new data set, so to check about the factor, and then come down to the 4 factors, and they also provide a short version because they noticed that so some author they didn't use the full scale 31 items, seems to be too much for conduct some study. So they now got down to the 4 scale, they merge some of the factors, and again they validate it to achieve psychometric properties. So this is the 12 items in 4 factors. It was published in 2018 in the journal. So yeah. So what did UES do better? So as compared with the previous example, so a formal publication was issued at each stage of the scale development. So the main author, O'Brien, so reviewed the application together with colleagues. So reviewed the application of UES in different contexts, very systematic, and also regularly they reflect on the usage. And then they report the psychometric properties and then discuss explicitly. And then they have a very clear guide in the 2018 paper to provide the instruction how you can use a UES in a short form. So they also give a word of warning if you're really tingling the questionnaire, how you should do it or should avoid doing that. So now we talk a lot about the questionnaire. So then we think about what we do beyond the questionnaire. So questionnaire is still powerful, but maybe not enough. So I think the mixed method approach, I think questionnaire is one of the common tool in our toolbox, but we have many other tools we can use or we should use to consolidate or to triangulate our findings. So I think many of you are already aware about interview, focus group, and also this or in our toolbox, in HCI toolbox, I would say. And more recently, it's all about the psychophysiological measurement, about the gaze, So EEG, ECG, name of this acronym. So it's measure different bodily response. So, and I talk about one of the actually, I asked Ray about the eye tracking because I'm really interested in this. So this is one of the papers we recently published about the gaze-based game research together with my PhD students. So, and then the main motivation underlying the work is how do young children, 5 years old, we're talking about here, interact with the digital educational games. We want to understand the cognitive, so the mechanism, so what did they look at and how they learn from it, but it's a quite difficult question to answer. But then we use the eye tracking methodology to study this question. So these are the resources that we use to build the game. So first we build on a game-based game-based learning model. So from this group of researchers, and then look at the current board game and other types of games to inspire our development of our own game. So, and also look at the curriculums, and for 5 years. So we can, then for the control studies, we still have a board game version of this game and a digital version play on the tablet. So this, and then we look at the recall and recognition, sorry. So, and then we use the scan path as eye tracking metric. So it's a gaze sequence. So look at, so it's based on the saccades and fixation. If some of you are familiar with the eye tracking, this is the basic the metric we use in this methodology. So it's inducing credit to a particular person and also particular target patterns. So what we use is the gaze sequence analysis. So we extract the information, not only which object they look at and the order they look at is somehow is also a very important relevant for us to infer the cognitive models of individual children. So and for eye tracking, so one thing, if you extract the relevant information, so one have to identify the AOI, area of interest. So is to link the eye tracking measure to a specific area. So in this case, you can see the game. So the instruction is one of our AOI. So the avatars, but the avatar is static. It's not a non-game, non-player character. It's a static avatar. And for this game is there's a moving train. So and then the child should really put the number into the correct sequence of numbers. Let's say 3, 4, 5, 6, or 8, 9, 10, 11, something like that. So this is the design of the game. And also on the left-hand side is to count the number of objects, and then they choose the right answer and put into the box. So we used a software called iPatterns. So with really quite resource demanding, we manually extract the gaze port, and then the iPatterns will extract the sequence, so-called the fixation sequence. So and then we try to understand the pattern. So individual child look at the game. So okay. So this is called a gaze subsequence analysis, GSS. So then, as I showed, that we use the eye tracker TOVIO Studio, and then the fixation sequence is you can see this B, 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 B. That means the child looked at that object B, the AOI, the area of interest, for quite a long times. That's why you can see 4B here. So, and then we reduce the fixation sequence to gaze sequence. That means we collapse the repeated objects into one. So we look at the order in which the object look at, not the durations, is of less importance for us. So then we look at the first 4. So you can see in the next slide, once look at the first 4, the B, A, B, C is that this particular child look at the AOI object. So then we calculate the score, the so-called GSS score. So you can see there is the A is instruction, B is the train, so and so. So then we map the sequence of individual child to look at the game to map so-called the efficient so-called reference. So ideally, the kids should look at the instruction first, and they look at the train, and they look at the answer option, and then pick the right answer, go back to the train. So, and then the C could be considered as a distractors. If the child always look at the C first, maybe the cognitive strategy is not that efficient. So we then calculate the score So this is more on the cognitive side. We look at them using eye tracker to derive the interaction with the game. But we also look at the affective experience. So we use the facial expressions to extract from the video. So for this work, we didn't use any GEQ or any game experience questionnaire. We use the video to extract the facial expressions. So yeah, and for the learning game, we use pre-test, protest, and so on and so. So it's also quite labor intensive. We manually coding by 2 researchers. So beginning, middle, and end phase of the interaction episode to derive the emotion. So, and reflecting on the eye tracking method, so it's a really generous, useful, really, as we demonstrate, we use gaze sequence. It's really insightful to know how individual child interact with the game. So, but then the current eye tracker is really not that child friendly. So we have to adapt a lot of this stand. So somehow is very clumsy for the child to deal with the tablet. So, and also the calibration. So because a child cannot sit still, so when you calibrate their eyesight is took quite a lot of time and effort to make them sit still. So, and also you can see that manually we have to extract quite a lot of data from Toby and use other software. So, and then we hope that in the future we can automate this process, yeah, to make it more efficient to use. So apart from eye tracking, there are also other psychophysiological measures. We can measure the game experience. So game experience is as I mentioned earlier, is a kind of user experience. So, and this is also one of the research area I've been working on about the measurability of user experience. So, but you may argue that, so of course, experience can be measured, emotional experience can be measured. So, but then the question is rather the measure is valid or meaningful. So you can measure anything you like, but rather it's really useful, not meaningful or not. It's depend on the theoretical model and the data collection tool and method you're going to the one used. So we already discussed it in the 2014 paper. So for the user experience, also maybe also that the game experience, we can use this kind of a questionnaire, the SAM questionnaire. So measure the pleasure, arousal, and dominance. So we can also use other physiological measure to like the GSR, heart rate, so and so. So actually using psychophysiological measure to measure game experience, so already started by Reagan and also followed by Leonard. So then they already published several papers on this along this line. So it's a real-time measure. So they measure GSR, heart rate, and breathing. So it's a very interesting work they have published. So, and they measure so real-time, so the physiological response. So, but we also think that somehow we can also use this objective, so physiological response to elicit self-report data, because somehow at the end of the day, emotion or experience itself is a very subjective thing. So it's nice that we have some objective data to support us, but at the same time, it's good to have some self-report data that stimulate or motivate us to develop or to apply a method called cue record debriefing. This is based in psychology. This is not newly invented, but we apply in a new context. So based on this is 2016 paper in Kai, so we measure the GSR and the heart rate, and also to see rather user we play back some video clips. So maybe I should go to the next slide. So you can see the setting here. So the gamer and the observer, the researcher in another room to capture the signals when the user varies some variables, technology to measure their GSR and heart rate. We also use eye tracker as a cue to elicit the response from user. So you can see here. So we look at the real time, where is the highest GSR peak, the skin conductance, and also at the highest and the end peak. So we look at also peak end effect by Daniel Kahneman. So, and then we noticed that, oh, there's the highest peak there. We play back the video to the gamer. So this is like a retrospective thing allowed in this case. So we asked them to tell us more about what happened at that particular moment, so they have a highest peak. So, and because during the gameplay they're so absorbed in the game, they didn't pay attention to it, or they cannot think aloud at the same time. So that's why you use this retrospective technique. So, but sometimes they cannot recall anything, so then it's maybe some kind of noise signal there. So, but anyways, I just demonstrate this is the methodology we use. So eye tracker is as a cue itself, but we didn't analyze the eye tracker data itself. So then we go further on. So the cue recall debrief. So we found that in that experiment, 2016 paper, is really user can re-immerse the emotions in that by viewing the video. So, but then how about the durations? Can it 1 hour? Or 1 day, or even 1 week? So apart, can they still re-immerse in the situation when they view the cue? The answer is yes, we could really play back the video. So, and this in the Tokai paper. So then we can, this is the curve we use, the optimal shift technique. So we can see the significant correlation between the initial emotional response and the so-called recall emotional response. So then we somehow demonstrate the robustness of the cue recall debrief it can apply in game research design and also evaluations. So, and all in all, this summarized that the multisensory emotion analysis. So this is can apply like in a serious game. So if you have a game to really support or train people how to control their emotion regulation, especially anxiety and depressions. So we can apply, measure this kind of variables to capture this data, and then use cue recall debriefs, because maybe we ask the participant to wear these variables all day long, and then play back the cue, and then they can relabel, annotate the emotions. So then we can, over a period of time, so the machine learning, then we can capture, so somehow, or predict the emotional the profile of individual participants. So then we can somehow develop a method to train the behavior. So this can be one of the applications of the serious game on dealing with the emotional conditions. So, but of course, this kind of technique, so we still a lot of research challenge to deal with, a lot of noise about a few different sensor data, and also what kind of cue. So in the previous example, we play back the video, so but maybe some photograph, and also maybe some voices clip you can play back to the user to elicit their cue to record the emotions during the daytime. So this is also one of the research questions we can look into, and also the context, rather they're together with some people or alone, so the emotion response also can be very, very different. We all know that, yeah. And also at the end, it's most important also the ethics concern. If you capture all this data, is very personal and private data. So then we talk about all these physiological measurements. So one thing that we know, that voice, like I'm now talking, you can see that I'm now in a hurry, so I talk very fast. So this is also the speech emotion recognition is also in the last 10 years is really advanced quite a lot. So, and we look at the speech size. So from that, we can tell about a lot of emotion a users has. So from the linguistic, the word they use, and also from the acoustic, loud, soft, or they have a high or low intonations. So this is typical, the machine learning approach. So to derive emotion from voice, so pre-processing, segmentation, fit into the data model and the classifications, then we can derive, so like this example. So when I speak to a software, it can analyze in real time how many percentage I fear and how many percentage I'm happy, so and so. So of course, this is still somehow work in development, so not yet very accurate, but we are getting there, I would say. So, and talk about this, the NLP and NLU. So it's really we use quite substantially in the speech emotion recognitions. So that basically, so the NLP is to try to understand what the speaker is talking about. And the NLU is going a bit further to understand the intent. So not only recognize the voice or words, but you also want to know, so what are the implications and what are somehow the sentiment analysis can be done by the NLU. So this I'm not going into details. So this is related to the voice control series game. So we can also use the captured voice of this kids. So when they're playing this game to train the speech therapy, we also can derive. So rather they are playing happily, or they feel bored, or they have some other emotions when they're using this kind of games to train themselves. Okay. So in summary, so the questionnaires is a useful research tool for evaluating game experience. So we cannot really deny this is still very important tool for us. And systematic calibration and validation of questionnaire over time is necessary. So as you can see, the two examples I present contrast the way, so how the authors develop the tools and track it over time. And also not only the author, so we as a user of a tool should also be somehow responsible, so-called the citation and reporting practice. So we should be accountable and transparent. So why we use this questionnaire and how we use it, and also report the psychometric properties. So it's a benefit to the research community when using certain tools lead to a valid results. And the eye tracking methodologies can get a very insightful data, but as I point out that there are also quite a lot of so-called issue to deal with. So especially when you use with the little child, so it's quite challenging. So, and also data analysis efficiency need to be improved. So, but this is a good tool to use. So, and the physiological measures. So quite often we use real time, but we can also use it as a tool to elicit some self-reported data, so that's subjective data. So using the cue record debriefings, we already demonstrated it can be robust to use. And the multisensory emotion analysis, so you can see all the different sensory data. So and it will become a standard approach. I will not be surprised later on. So you cannot just use single type of data. So we have to use different types to consolidate the results. So, but then, as I mentioned, that the data fusion still is quite a challenge. So for the community to calibrate the results we get. So then this is something we have to work together as a community. Yeah. So this is all I want to say. So thank you for the listening. I hope that today is no technical problem so far, hopefully. Okay, thanks. Welcome to discuss any question with the audience. So,
Effie, thank you for the wonderful presentation. So just to check if there are some questions in the audience.
Hi, Professor Law.
Hi.
I have a question.
Yeah.
I have a question about this physiological measure. We are analyzing the problem, and it's quite difficult to apply for the serious games that it's longer than 15 minutes. I mean, then the flow of data that you are getting through these devices, for instance, heart rate, galvanized skin response, all these kind of things. There's plenty of data, and usually those systems are thinking for shorter time experience. I mean, what is your experience with that? Because I mean, we are having serious trouble, I mean, connecting all this information and trying to relate it to the actual analytics and interactions.
Yeah, so I can fully, I would say, as sympathetic with the difficulty. So actually, so I show about the GSR and the heart rate. It's really difficult for us to calibrate. A lot of noise. So suddenly we get 10 standard deviation from the baseline. It cannot be like that. So because so the device is also very sensitive to the user movement. So it really took us a long time to do the calibration. So actually, we still have the EEG data within analyze, because it's really a lot of noise, and the device we use are not that stable. So either, so I would say that, so the whole community working on the psychophysiological measures still try to do this kind calibration. So as I think one of the questions in the previous talk to Wayne is very interesting about the game analytics. So I will also ask, can people working on the psychophysiological measurement can also come together to share the data? So because of calibration, so then we can have a data set, we can have a good reference to compare. So but now still we'll work on the individual research group. So maybe, hopefully this will be the future effort to bring different group working on psychophysiological data to build a database, then we can do a more meaningful analytics. But now, so we really, I can fully understand the struggle you're facing. I'm also the same. Yeah.
Okay, thank you very much.
Thank you.
There is a question from Manuel.
Yes. Hello, Effie. Thank you so much for your presentation. Really interesting. I'm also working a lot on using physiological signals, so I feel a lot of the problems that you're having, and also felt the sentiment of what Balthasar was mentioning. One critical point for me always when using physiological measures is we always want to compare them to usually subjective measures, and this is the ground truth. But I think this is like a very big problem, because the ground truth is sometimes, you know, playing for 10 minutes and then asking how did you feel, but you have like 10 minutes of pure data. How do you compare that to one single data point from your questionnaire? And then it's, to me it seems obvious that the correlation is not always that high. So I don't know, I just wanted to pick your brain on that issue.
I fully agree with you. So, and in the 2021 paper in Tokai, so we have really lots of GSR data within, let's say, 5 minutes. So, but only one subjective self-report data with the same data. So then methodologically, it can be quite challenging. So how can you map 1,000 data to one single point? I fully agree with you on these issues. So, but we end up there. So we kind of use this, I mentioned about the optimal graph shifting is done by my colleagues, not by myself. So, but then we try to overcome this by some mathematical modeling. So, and one point I also want to talk about I forgot, it will come back to me later. So, but I fully agree that this is the issue that we are facing. So it's very so-called in quotation mark easy to collect a lot of the physiological data. So, and yeah, the self-report data. So about this, the voice emotion. So from the literature, actually, so even human, so recognize emotion in another human, only 60% accuracy. So if human to human is like that, how can you expect the machine can learn from us? Because the ground truth is not true. So in some sense, so then we have the ground truth to compare. Exactly. So I fully agree with your observation. Yeah.
Thank you so much, Effie.
Thank you.
Effie, there is another question from the chat from Isa. Do you think, what do you think about facial emotion recognition?
Actually, I can maybe say it orally too. Yeah, my question was, there's so much data and so many methods. What would you suggest? Which are the most accurate, and which ones should be combined to get you know, the best result? I mean, obviously this depends on what you want to do, but can you enlighten us?
So yeah, I wish I could get an answer from somebody. So, but for me, so I cannot. It's really an easy response is it depends really on the application. So, but I could say that facial, as I think is somebody right about the facial expression. So it has been established so for quite a long time. So about a lot of coding scheme. So and also a lot of device used to measure facial expressions automatically. So in terms of being established, so I think facial expression is the way to go. So, and also voice getting more because now we have more voice-based interactions. So and also in the last maybe 10 years, I would say the voice emotion recognitions get more prominent, so and more accurate. So I think for me, if my personal interest, I will pick the voice and facial expressions. But of course, other researchers may disagree with me totally. So, and there also, I didn't mention about the gesture, about body gesture and the guide, the way you walk. So all this can derive emotions. So I really have no so-called full sure answer for you. But so in terms of being established, so I think facial expressions is quite a lot of literature and coding scheme we can use, we can rely on. Yeah.
Thank you.
Another question from Milos. Is there, in your opinion, any key method to get data showing cognitive process during playing game?
Any key method to get? Okay, so this is more question for me. So yeah. And for the cognitive, so it's showing real time, I think is difficult. So I demonstrate we use eye tracker. So but still it's not real time. We also have to use the post gameplay analysis. So I don't know. So I'm sorry that I cannot give you a very good answer to this. So yeah, but I think using eye track is one way to gain insight. So we also think aloud. So in HCI we say ask the user to talk all the time, but experience told us that the think aloud. So in many of the cases that I guess, at least in my experiment, so not that insightful to gain into the into what the participants are thinking. So it gives some hint, but not really full perspective. Or still we have to need some maybe post-game interview, or I also always use the kill record debrief, can gain some insight to what they're really thinking or what feeling at the time they are interacting with the game.
Okay. Just checking. It seems there are no more questions for you, Effie. So thank you again to be with us. And I think, Francesca, that both the presentation and also the recording of our 2 keynotes will be available on the website. So many thanks.